All right. Well, I'm gonna say we're starting now. So, hi everybody. My name is Fraser Kane. I'm the publisher of Universe Today, and once again, it's time for our weekly space hangout, where we round up all the space and astronomy news that has happened in the universe and talk about it and explain it for your interest. So again, I am joined by all of my space friends. And again, this is in no particular order of what you're going to see. This is only the order that I see it in. So I see Alan Boyle from MSNBC's Cosmic Log. I see Emily Lakdawalla from the Planetary Society. I see Ian O'Neill from Discovery Space News. I see Nicole Gallucci, the Noisy Astronomer. And I see Dr. Pamela Gay, my co-host at Astronomy Cast and blogging at starstrider.com. All right. So
this sounds like Romper Room. Do you remember that show?
Yes.
Really? No. I don't know if I watched it.
Somebody holds up a mirror and says, I see Johnny, and I see Patty, and I see everybody else. So there you go.
It's just like Romper Room. Everything old is new again. All right. So this week, we're going to talk about the search for super Earths, the possibility of life on Venus. Possibility. New images of the far side of the moon, nature versus nurture in star formation, and the test firing of SpaceX's new super-duper rocket. I believe that's the name for it. So first, why don't we start with Alan Boyle, who is going to talk about the discovery or the search for super Earths. And I guess you guys blogged about this quite a bit this week, right?
Yeah, super Earths seems to be a hot topic. I wrote about Dimitar Sasolov, who created such a stir a couple of years ago when he said that there might be millions of Earths in the Milky Way, and now the sense is that there might be billions of planets that are around the size of Earth, maybe as much as 10 times as massive as Earth. These are called super Earths, and it's thought that they're perhaps as conducive or more conducive to life than our own Earth. The way Sasolov sees it, the bigger the better, until you start getting into the Neptune range, that a bigger planet is able to hold on to its atmosphere. It has a more active tectonic plate system going on. And so that's in his view, that's why Earth made it in terms of having life, and Mars didn't. That Mars was just too small to hang on to its atmosphere and didn't really make the grade. And so we've got another super Earth that is being announced today by some researchers at the Carnegie Institution of Science and University of California at Santa Cruz, other places. And this super Earth is particularly interesting because it's only 22 light years away, and it orbits one star in a triple star system at a distance where water could conceivably exist in liquid form. And so that's what you call the habitable zone, or the Goldilocks zone, where it's possible for life as we know it to develop. And so there's another super Earth to add to the list, and we're starting to get dozens now because of the Kepler planet hunting mission, as well as other planet hunting missions that use different techniques to look for these things. And as the Kepler mission goes on, as we've talked about in past Hangouts, we'll be getting more and more of these smaller planets, and really start to get, it's going to be so that you can't tell your planets without a program, that there could be hundreds of these worlds that could sustain conceivably life, and would be prime targets for future missions to look for the signatures of life in their atmospheres. So,
but what about the crushing gravity of a super Earth? I mean, wouldn't that just make everything just be worms, or I guess in the water?
No, there are a couple of reasons for that. One is that, well, okay, you're talking about a world that is maybe 4 or 5 times as massive as Earth, and so you think, oh boy, the gravity must be 4 or 5 times as strong on the surface, but actually it's going to be bigger as well, and so it's a more complex interplay of the density, volume, mass, size, that sort of thing, and so it doesn't scale that way. And another thing, what Sasolov pointed out, is that when you're talking about the effect of higher gravity on small biological structures from which life is built, it really doesn't have that much of an impact. So maybe we're talking about the kind of planet that Superman grew up on, or the Incredible Hulk, or somebody like that, that the biological structures would be stronger in order to withstand that higher gravity. And so they don't think that's a big factor. Yeah, that's right. Getting off the planet. When I wrote about this on the blog, some people pointed out that it might be a little harder to achieve escape velocity and get off that rock. So that's something I hadn't thought of, and definitely it's something for science fiction fans and astrobiologists to puzzle over. Maybe there's life there, but they just can't get off the rock.
So what are the plans then to actually be able to follow up some of these observations and to be able to actually determine if there's life on some of these worlds?
Well, Sasolov has been given a lot of thought to that, and there are two strategies. One is to have something like Kepler, perhaps, now that they know that there are good statistics on finding these other worlds out there. You can start to have a telescope that is not just staring in one direction, but is able to look at the nearest stars, and that's the one. Those are the ones that you want to target, because the closer the star system, the easier it might be to do the detailed observations that can tell you about the geochemistry or the atmospheric composition around that planet. And the other strategy is to have ground-based systems that look at a particular type of star called M-dwarf star, and those are stars that are smaller than the Sun, and it's a little easier to pick up the signature of a planet around those types of stars. And in fact, the star that was involved in the discovery that was announced today is an M-dwarf class star. So those are the two strategies to try to get to the next step of determining not only that a planet exists, but try to say something about that planet and its atmosphere that could eventually lead you to determine how friendly that planet would be to life as we know it, or
Pamela,
as we don't know it.
Oh, Pamela, I know you're very cynical about M-class stars, right?
Well, so the issue with M-class stars is when they're young, they love to give off high energy bursts, and so for their first billion or more years of life, they're just going to be irradiating everything near them. So I have to admit that it's one of these things where either the life has to develop late or has to have the ability to deal with all sorts of high energy radiation that we just don't see how any molecules could survive.
Well, M-dwarfs live for tens of billions of years, much longer than the Sun, so it's possible. And they make up like 80% of the galaxy. So yeah. Hopefully they're not all sterilizing their planets.
Well, they do all systematically go through this early billion years of high energy flare activity. So the question comes, here in our solar system, our sun happily sterilized the inner solar system. Then the age of heavy bombardment brought all the materials in. So the question is, can you have that period of bringing in materials occur later in the solar system's life and unsterilize the inner solar system while the sun is calm?
Okay.
All right, why don't we move on to the next story then? And this is, I guess, Emily, you're going to tackle this one, which is the discovery of life on Venus? No. But before we do, can we see an update of your latest, what is it? Your little
Anybody recognize this one? Coming to a red planet near you in August is Curiosity rover here. And then we also have, with its sunshade and its rotating solar panels. Notice that I've made Messenger with some bright silver solar panels, because in fact 2/3 of Messenger's solar panel is actually mirror. It reflects away most of the sunlight that strikes it, because otherwise they would get too hot. So only the little black lines there are the solar panel material, or the solar cells, I mean. Anyway.
Can we see Curiosity again?
Oh, sorry.
That's adorable.
And I want to point out that the wheels are actually made of a well-known gray metallic mineral called hematite, which is what brought opportunity to Meridiani Planum on Mars. So I thought that was fitting for wheel material.
Nice.
That's amazing. Please keep this up.
I will. I plan to. So anyway, getting back to the life on Venus story, which I'm going to, spoiler alert, there is not any evidence for life on Venus in the Venera 13 images. unfortunately. The story came about because there is a Russian planetary scientist named Leonid Xanfomality, if I'm pronouncing that correctly, something like that, who is actually a very senior statesman in Russian planetary science. He built instruments for basically every Venus mission. He was the one who discovered lightning on Venus through one of his instruments. So this is a for-real scientist and engineer who seems to have gone off the deep end a little bit because he decided, after having seen that there are some extreme environments on hot Jupiters around other stars, that maybe there could be life there, and if there could be life there, then maybe we shouldn't have discounted the fact that there could be life on Venus, which, as far as that train of thought goes, is okay. But then when he got back to looking at the Venera lander images, and particularly Venera 13, which landed on Venus in 1981 and returned some really cool pictures, he decided that he saw all kinds of interesting shapes that he called scorpions and giant shells and disks and vanishing shadows and various other things that he has decided are actually life forms moving about on the planet. Because he's such a statesman of Russian planetary science, I actually took seriously a paper that I probably would not have given a second thought, but once I got that far and looked at what he said he saw in the images, it's clear it's like another case of seeing Bigfoot on Mars, or, I don't know, life forms swirling in exoplanet atmospheres. There's absolutely nothing there, and it's really kind of sad, actually, to have this come out from such a well-known scientist, and also coincidentally at a time when there's some pretty bad PR for Russian planetary science with Phobos Grunt crashing to ground, and them talking about flying Phobos Grunt 2 in 2018, which is patently not going to happen unless they reform what's going on in their industry. So move along, no life on Venus, at least not in these images, and let's talk about some science that's actually happening on Venus, please.
Well, I mean, is there any possible way that there could be life on Venus? I mean, I know, the surface is a hellscape by our definition, but then again, people are finding life in stranger and stranger places here on Earth. But I know also that the atmosphere of Venus has, you get high up in the atmosphere and you have almost Earth temperature, Earth pressure in the clouds. You
do, but you also have clouds made of sulfuric acid. It's a very corrosive environment. It's an extremely dry environment. Venus has lost most of its water. And nearly all of its carbon is actually in its atmosphere. It has about the same carbon budget that Earth does, but where Earth has almost all of it locked in limestone and other rocks in the form of calcite, it's almost all in the form of carbon dioxide up in Venus's atmosphere. So I wouldn't say that there's absolutely no possibility that there is life on Venus. I wouldn't say that it couldn't have originated also on Venus at some point in the past. If it started spontaneously on Earth or Mars, it could certainly have started there. But I think it's one of the less likely places in our solar system to find it now. I think it'd be much more likely to find it on Mars or Titan or Europa or even Enceladus than Venus, which is really a pretty terrible place. It's hot enough to melt lead on the surface. It's a very corrosive environment. Very acidic, molecules get broken up, and there's no magnetic field either, so you do get, at the top of the atmosphere, you also get a lot of radiation. So, nasty place.
It's one of those situations where it could have used being a super Earth with that extra gravity to hold in its hydrogen, right?
Yeah, it could have.
All right. Well, let's keep rolling then. So Pamela, and this I guess this story just happened just a couple of days ago, right? Which was that we've got some new images of is it the dark side of the moon? Is it the far side? No, it's the far side of the moon.
The far side. So our moon, we're cursed with only ever seeing one side of it, and we've all gotten to know that one side really well. And luckily, it's kind of the more interesting side with the dark mare and the light regolith. But the pair of Grail orbiters that are up there right now mapping out the gravity of the moon, the spacecraft that's named Ebb, it also has on it a video camera that was designed for middle school kids. Yay, she has a little one of it too. It has what's called the Moon Cam, and that was designed for middle school kids who should now clearly also in their art class be building spacecraft and in their science class using spacecraft. It has a camera for middle school kids to use to explore the moon for themselves. And this particular instrument is led by Dr. Sally Ride, who was the first American female astronaut. And they just released their first video, and it's this spectacular video that's up on YouTube that starts out kind of grainy, and you're like, really, this is a NASA video? And then it gets all the gain and contrast right as it passes over the backside of the moon, and for the first time you see this completely different landscape that is much more reminiscent of what we're used to seeing on Mercury, where even the cratering pattern is completely different. You see mountains. It's just like looking at a completely different planet. And it really brings home the moon has two geologically completely different sides to it. So I'd encourage everyone to go out, take a look at this fabulous video. We'll link to it in the notes to this show. And if you're a middle school teacher or you have a middle schooler, find out how to get your kids involved in using a NASA spacecraft to do your science fair project. How much cooler can that get?
As far as I know, there are still slots available for classrooms to sign up, and even if those run out, they are actually now talking about an extended mission, and they're going to re-propose for more classrooms to participate in the MoonCam program. Also, I wanted to mention that I did a little math and figured out that the video that they took was from 40 times farther away from the moon than they will be during their nominal mission. So the videos are going to be 40 times higher resolution, but also cover a 40 times smaller width when they actually get to their nominal mission phase.
And the only real limit on how long this can go is, unfortunately, the Grail mission being solar powered, they're kind of concerned that during the next lunar eclipse, the missions are going to be in shadow for so long that they run out of battery power, and that could be death. But then again, NASA's getting really good at building things that live far beyond all expectations. And we could get lucky and have this mission going far into the future, allowing better gravitational mapping. Now, maybe not. Emily's shaking her head going no. And this one is a highly doubtful. It will likely die, but there's hope.
No, well, actually, it's one of those things where they didn't want to overpromise before they launched. So before they launched, they said, we are going to die in the next eclipse. It turns out that after launch, they're like, well, we're a little more robust than we thought. We're going to survive one eclipse. And they probably could survive another one, but the issue is actually that they're orbiting so close to the moon that there's a lot of perturbations to their orbit, and basically they're going to run out of fuel and they are going to crash. They are not going to survive for another cycle because they just don't have enough fuel to stay up in the air. Or I know there's no air up there, but they're definitely going to crash into the moon. One cool thing is, though, that they will be orbiting a lot closer to the moon at 25 kilometers, and they have determined that moon cams will still work at that altitude, so you're going to get even closer, 80 times closer than these videos during the extended mission.
And I'm sure there will be some great crash videos sent back as well.
I hope so.
Are we going to have to resurrect the hashtag bomb the moon?
Oh, right,
Oh gosh.
Right. That. So Pamela, I'm going to give you one quick bonus story, which is that you wanted to talk about the fact that Eros, the asteroid Eros, is in opposition right now, and its chance to contribute to some science.
Right. So the asteroid Eros is perhaps most well known because it was one of the first asteroids that got an up-close and personal imaging experience. About a decade ago, the Shoemaker-Near mission not only flew past but then orbited the asteroid and eventually landed on it, sending back just absolutely amazing videos. And right now, the planet Earth and the asteroid Eros are remarkably close to one another. The asteroid has a non-circular orbit. It's kind of elliptical, and here's the sun, and then as the Earth goes around, most of the time you end up with Eros and the Earth fairly far apart, and this greater distance causes Eros, even at its closest, to not be easily visible in binoculars. But every once in a while, now in 1931 and 32, or 1931 rather, 1901, all of these different random by thinking but lined up by orbital time periods, we end up with this wonderful alignment where Eros is sufficiently close that you can see it easily with binoculars. And not only that, but you can actually use it to measure the size of our solar system. Now, the way we do this is you put observers in different places on the planet, and you look to see how Eros lines up with the background stars. This is the same sort of thing that surveyors often do, or you can actually replicate the experiment and pretend that one eyeball is Boston and the other eyeball is, say, the Caribbean. hold up your finger, call it Eros, and blink between two eyes, and you can see your finger going back and forth against the trees, which you can pretend are stars. Now, writ large, we have a planet full of people with DSLR cameras who can go outside, take measurements of Eros by photographing it and writing down where they are, what type of camera they used, what type of lens they used. There's iPhone apps that you can get your timing just right, and then submit this data. Now, what's awesome is we learned from Kepler exactly how the ratios of orbital periods relate to the distance that objects are from the sun. Using those basic equations, we can use our knowledge of Eros's period. We can use triangulation to get the distance between us and Eros. We can use the measurements of the distance between humans on the planet. Lots of little factors go in, but all things that can be done by anyone with a DSLR camera. And we can recreate the 1931 measurements that allowed us to measure the size of our solar system so accurately that the numbers weren't improved until we started using radar in the 1960s. Now, yeah, we're now using radar to do this, but what's cool is there's a group of people led in part by the Astronomers Without Borders program that are collecting all of these different images. This is Stephen Van Rode and Michael Richmond. They're collecting all of these images and putting them online to allow classrooms to recreate these experiments. A lot of times in class we say, and historically people did such and such, and it means nothing. Well, now we can go, historically people did such and such, and here, why don't you do exactly what they did? And so this is a chance to get involved in astrophotography, to see an asteroid when it's close enough to be seen with binoculars, and to help make science make sense to kids, all in one foul swoop. So we have all of that linked to CosmoQuest.
And this is probably going to make you happy, Pamela, but we're going to try and do a virtual star party tonight, I'm thinking, and Mike Phillips is going to try and image Eros as part of this project. So we're going to sort of do this live.
That sounds great.
That is the plan, but I make no guarantees.
And this is visible to people in both the northern and southern hemisphere, so no one has an excuse unless they're standing on a pole. All right. Well, you fulfilled your cause for science. Let's move back on to the to the news. So, Nicole, you worked on a story this week about the nature versus nurture for star formation, which some new research coming out of the Gemini tells us. Yeah. So it's big unanswered, field of research in astronomy right now is galaxy formation and evolution. So how do galaxies evolve over cosmic history? How does that affect, which then affects star formation, which affects planet formation, which affects life. So it's kind of the big grand scale of things. And so this group from this is the Gemini Cluster Astrophysics Spectroscopic Survey. They surveyed 10 galaxy clusters that are about 7 billion light years away, so back when the universe was about half the age it is now. And they took spectra, so they split up the light of these galaxies into their rainbow of colors of about over 700 of these galaxies to look at the properties and how much star formation was there in the past, how much star formation is going on now at the time, not now. And what they found was that there's, like most questions that in science that ask, is it nature, is it nurture? It's both. So the environment that the galaxy's in. So the galaxy cluster itself, you can kind of think of that as like a city of galaxies, right? And you have the downtown where it's denser and galaxies can brush past each other and cause weird stuff to happen, either turning on or turning off star formation. And then out in the kind of the suburbs of the cluster, it's the galaxies aren't brushing past each other as much, and so where they are in the cluster determines some of their star formation history, but also the mass of the galaxy itself. That's the nature part. At some point, it's going to run out of gas to form stars, and that's going to kill off its star formation. So what they found is that it's as you might expect, it's a little bit of both. Oh, and I will put a. I actually found a picture of the galaxy clusters. It wasn't in the press release, but it was in the paper, so I'm going to put that in the chat link.
Well, this is one of those situations where you're kind of going back to the original research and then trying to translate it
Yep.
into something that is sort of consumable by the public. So
yeah, because you can read the press release and get an idea of what's going on, but I like to go back to the paper itself, or the preprint that's on the AstroPH archive server, and read the papers. I usually don't understand the details of optical observing as well, because I do radio.
You're a radio person?
We'll convert you to the dark, bright side eventually.
The dark, bright side, yes. I took a class in it. So I don't always, but reading the paper, you kind of get a sense of what the scientists were thinking when they worked on this study and what they came up with a little bit better.
All right, so I think we'll keep rolling. So Ian, you've got a cool story about SpaceX's new rocket tests.
Yeah, well, exciting times for commercialization of spaceflight. And probably the world leader in this is, of course, SpaceX, which was founded by Elon Musk, the PayPal founder, so he plowed all his money into SpaceX. And now they're working on getting some contracts with NASA, and NASA's basically providing some money for developmental costs. And in this most recent development, SpaceX has test-fired their Super Draco, which is a rocket which isn't a rocket to launch stuff into space. It's actually to rescue astronauts. Now, if you think back to the Apollo era, there was a launch escape system attached to the top of the Apollo capsule, so that when the Saturn V launched, if there was any emergency during those first few minutes of launch, I think it was, the first few minutes, I think either the astronauts or ground control could control when this launch escape system fires. So basically they hit the button and these rockets would fire from the top. It's that little pin on top of the capsule, and it would pull the astronauts clear. Now, it's probably going to be one hell of a roller coaster ride. You couldn't imagine the G-forces of being launched from a launching rocket, which would be quite nuts. But basically, with SpaceX now, they are trying to develop this launch escape system for their Dragon capsule when it gets launched atop the Falcon 9. Now, this is not only important for astronaut safety, but also SpaceX thought, hold on, so we've got these rockets attached to the side of this Dragon capsule. Say if they don't get used, which they probably won't get used during launch, it's only in case of emergencies, wouldn't it be cool if we can use it after the fact when we actually go into space and actually start visiting, start in orbit and then perhaps visit other planetary bodies? So they've proposed it has a dual use. So basically it's going to be a launch escape system, and it's also going to be a propelled landing. So basically they're going to use the Super Dracos. There's going to be 8 of them attached to the outside of the capsule, and they're going to use it for precision landings on Earth. But also a few months ago, SpaceX announced they want to go to Mars. So they produced this wonderful video of the Dragon capsule doing a vertical landing like a helicopter, held up by the thrust of these 8 Super Dracos. Now, and the best thing is also with these Super Dracos, they use the same fuel as the Draco thruster, which is a small rocket. I think there's like 18 of them attached to the vehicle, so that when they're in orbit, they're going to be used for maneuvering in orbit. So basically, they're going to be using the same fuel as the Dracos already attached to the spacecraft. But these Super Dracos are just fierce rockets. They burn. I think they burn the fuel 200 times faster than the Dracos already attached to the Dragon capsule. So they're going to produce a lot of thrust, and you need a lot of thrust, and you need instant thrust when you've got an emergency launch system, but they're also going to be used for powered landings. So it's kind of exciting, and we're kind of waiting on the date now for when SpaceX carries out their first orbital docking with the space station. I think it was supposed to happen. It was originally scheduled for around about now, but I think it's been postponed. But with SpaceX, you just got to keep watching the news, because they will announce within a day of when they're going to do a launch attempt. So just keep watching the news feeds and keep an eye on what SpaceX is doing, because they're doing some really, really cool, exciting stuff. And this is, And one thing I really like about SpaceX, because there's a lot of pessimism around human spaceflight, but there seems to be one very small component of the US industry that are trailblazing in this area with NASA's help. So it's kind of a cool thing. And this Super Draco test firing is just another step along the way to getting humans back into space.
We've all been reporting on SpaceX for 5 years now, and I mean I think we're all placing a lot of our hopes and dreams in Elon Musk's vision and being able to actually pull all this stuff off. And how do you feel about all of these various announcements? It feels like they're announcing a lot of plans while they're still trying to get the fundamentals actually done. I mean, they've only just tested and actually their original rocket and taken a wedge of cheese into space and brought it safely back to Earth. I mean, and then announcing plans to go to Mars and such. I mean, where do you sort of put that on the whole timeline?
Yeah, it's hard to get too enthusiastic because we know with space, anything to do with space travel, we're still in our infancy. So to see this this very young company in many ways. I mean, SpaceX has only been around for less than a decade, 8 years or something. So they're coming on very fast, and they're building their own rockets. They're building their own technology with NASA's help. I mean, they're not doing this completely alone. They didn't sort of wake up one morning and think, I'm going to build a rocket, and start from first principles. This is based on decades of rocket technology, but they are developing their own systems. So that alone is really exciting, and also with NASA oversight, because NASA is providing funds. I mean, NASA's got these commercial spaceflight programs that provide seed funding to develop these technologies. And in fact, this Super Draco rocket, probably more impressive than the technology itself. They actually designed and built this thing within 9 months. So they're developing stuff at one hell of a rate. And so, and as you say, I mean, they're pretty much untested. They've done one orbital test of the Dragon vehicle. They've got quite a lot of failures under their belt. If you think back to the Falcon 1 when it was being launched in the Pacific, it took, what, four tries before they actually got a successful launch of the Falcon 1. Now, if you think back to the Falcon 1, that's kind of a vague memory, because now we've got the Falcon 9, which is a big, beefy rocket, and that's undergone some good test flights. It hasn't had a launch failure, so this is good. So now we're waiting for the Falcon 9 launch of the Dragon vehicle that's going to dock with the International Space Station. So it's just like these incremental steps that SpaceX seems to have been taking in their stride. They've taken the failures and chalked it down to experience, and then moved on, which is a nice. I think it's a nice insight into what goes on in commercial spaceflight, because there's going to be a lot of losses, but there could be billions of dollars to be made. So, and Elon Musk just so happens he's got a lot of money behind him, a lot of success. He's a very good businessman, and he's built this company from the ground up. And ever since I visited the SpaceX headquarters in Hawthorne, just down the road from me in LA, I've been hooked. I mean, to see them build, back in 2008, they hadn't even had I think they just had their first successful Falcon 1 launch, and that's why I was there. And to actually see them fabricating these rockets just down the road, it was in a very small hangar. It's almost a cross between NASA Mission Control and Google headquarters. So it's very trendy. The people there were generally very young, very space-agey, and it just inspires me. And I think once we start seeing SpaceX doing delivery runs, which they're going to be paid for by NASA, to the International Space Station, I think then we'll start seeing a lot more international enthusiasm, because that will be the first commercial docking with the International Space Station. So now we've just got to make space reusable, we've got to make it profitable, and we've got to make it safe. And that's pretty much what NASA's trying to do. And especially with this launch escape system, they want to basically rescue astronauts when they start doing taxi rides to the International Space Station. So they seem to be covering all bases. So big thumbs up from me.
That's amazing.
I was thinking that it almost sounded like you were drinking the Kool-Aid, but I know you're such a beer fan that could never happen. I just wanted to add a couple of things. One is that right now the plan is for SpaceX to do that demonstration flight to the space station around late March, but Ian is right. With SpaceX, you just never know, and that's part of the frustration, but also part of the beauty is that you have this flexibility that SpaceX has. Another thing is that SpaceX isn't the only game in town, that there are other companies, Boeing, Blue Origin, which is up in my neck of the woods in the Seattle area, even though we don't hear all that much about them, and Sierra Nevada, which has their space operations in Colorado. And just today, NASA announced that they delivered a flight test vehicle, and they'll start having actual flight tests of the Sierra Nevada Dream Chaser. And so there's a lot going on. It's not just SpaceX, but definitely SpaceX has been the leader in this field.
One of the things that really struck me with this was, I want to say it was about 6 months ago, the Chinese came out and actually said that they wouldn't be financially competitive compared to SpaceX. They just couldn't build rockets as cheaply as SpaceX seems like they're going to be able to do. And I really think the paradigm for looking at Elon Musk's work is Howard Hughes, no mental disorder. So you take that brilliance, you take that funding to take dreams into reality, and then remove all of the things that made for an interesting movie and not a particularly as successful as it could have been career. And this is what I see.
I think there's another element too, and that's maybe a lack of fear, or at least a healthy amount of fear. NASA is so fearful with human spaceflight these days, and I think that the private companies are willing to take on quite a bit more risk. It was interesting as I was listening to Ian talk about the possible dual use of what is after all an emergency escape rocket. NASA, I can't imagine they would ever do that. They would say, we cannot possibly add any other function to something that is a safety mechanism. Absolutely no way that they would complicate it in any way to compromise the safety of the astronauts, whereas a private company that's seeking to make literally more bang for their buck are willing to look into dual uses for things like that. And that kind of thinking you just won't get out of NASA. You actually really need private companies to take that on for you.
Yeah.
And it goes beyond risk to just things like, well, how do you write the piece of paper to hire someone to do Part A and Part B and let the same person do A and B? There just isn't a paperwork mechanism, and when you're dealing with federal grants, you get stuck in paperwork hell occasionally.
Yeah, we do all definitely sound like we've been paid off by big SpaceX at this point, but I think, there's a real psychology going on here, that there's so many people who have been waiting desperately for human spaceflight to get back on track and take it to the next level, and seen so much just kind of fumbling around and orbiting the Earth again and again and again, and all of those dreams of moon bases and explorers on Mars just never happening. And then finally we get somebody like Elon Musk who shares our desire for that next level of space exploration, maybe even more than us. I mean, he's a real fan of space exploration, and at the same time has the resources and the capability and the connections, and the entrepreneurial spirit. So I know we're putting a lot of hope in his plans, and I know that we all definitely sound like we're sponsored by SpaceX. We're not. We just this is it. This feels really real from the moment
we just want to ride on the craft.
Yeah, the moment you hear Elon Musk say that this is what he plans to do, then you got to take it really seriously, and I think it's really exciting.
Yeah, it's very hard not to get excited as well. I mean, because I work for a news organization, so if I did an article, and not necessarily blog, because if I'm doing a blog, I can rave about it as much as I want. But it's very difficult to write an unbiased piece, especially when you've been there, seen the rockets. The school kid comes out in you a bit, and also because they don't have that kind of history. I think everybody with NASA, everybody has that slight pessimism because it's a big organization, it's funded by the government, it's got a lot of negatives against it, even though they do amazing stuff, and NASA's not going anywhere. But I think when SpaceX comes along, it doesn't have that history, and it's kind of new, and it's got that Google appeal, it's got that coolness, and everybody is kind of talking about this company called SpaceX. It's got a cool name, SpaceX. I mean, brilliant name. So I think it's got the coolness factor at the moment, but that's why it's critical that they get it right. The next launch of the Dragon capsule, they're very confident that it's going to work, but it's a brand new thing. I mean, obviously they're getting a lot of help from NASA, they're getting a lot of help from, you know, industry professionals, but ultimately it's going to come down to that one launch. And if it fails, yeah, Elon Musk will put a positive spin on it. He has to. He's the CEO of the company, and you mustn't lose sight of that. He wants to make money out of this. So, although it's cool, you've got to be slightly reserved. But you can still jump on the bandwagon and, you know, promote it as it is, because it's a great field.
Yeah. All right. So I think we've covered sort of the scheduled part of this episode, and so we've got probably 15 minutes to take some questions from the audience. So before we do, though, if everyone can +1 the stream if they're watching it on Google+, that will let us sort of get a rough idea of how many people are watching. If you're watching it over on CosmoQuest, I don't think there's a way to connect it together.
You can @tweet us, and if you +1 at the bottom of the page, I do keep track of how many pluses there were before and after the show.
And then and also it's good to know that in the future, if you're watching this on Google Plus and you're sort of worried about when the show starts up and you're going to miss it, it's easier and more convenient. You can actually watch it on our cosmoquest.org/hangouts page. We've got the video embedded into that page, and you can just turn to that, 15 minutes before if you want, 10 o'clock Pacific time, and then you can wait, and then the moment the show starts, it'll flip over and you'll hear the audio, and then you can start to watch it.
Yeah, no reload required. It just reloads the page for you when we put the show live.
Yeah, so it's a much more convenient place that you can watch that. So that's sort of our recommendation. So what I'll do is I'll go through the list of comments and questions, and I'll look at the tweets that have been delivered and see if there's any interesting questions. I know there was one. Actually, Mike Phillips, who's one of our superstar astronomers doing our virtual star parties, he had a question for Ian. What's the driving force behind the proposed Mars mission? I guess this is the SpaceX Mars mission. What is sort of going on there?
It's hard to tell because, as I said, Elon Musk, he wants to make money, and ultimately he wants to provide the space infrastructure to do stuff in space. Now, this is a different kind of thinking than like NASA saying, okay, we're going to go to Mars, and then everybody starts asking, how in the hell are you going to do that? And then they go, well, we have to build the rockets, we have to build the space station, we have to build all the components that go into a Mars mission. They build from the ground up. That's why it costs so much money. Elon Musk has come forward with a concept with SpaceX, and commercial companies are the same. They want to have a mechanism in place that big companies and government organizations like NASA will hire them to do stuff in space. So Elon Musk is fixing a problem. Basically, our problem is getting stuff off Earth. I mean, it's so basic. We're just trying to put stuff into orbit. And up until now, we don't have a routine way of getting into space. As is proven with the space shuttle when it was retired last year, we've got no means of getting US astronauts into space, and we have to pay the Russians to do so. I mean, it's such a weird scenario. And if 50 years ago you said this is going to be the way it is now, they think you're stupid. There's no way that we'd be relying on the Russians to put stuff into space. I mean, the Russians just so happen to have the most efficient means of getting to space, the Soyuz capsule, but there's a bit of concern now about their space industry. So basically Elon Musk is saying, look, I've got a solution. We're going to build rockets on the cheap. We're going to do it our way. We get NASA funding to do so. We're going to put stuff into orbit. Now, an extension of that is he's basically saying if NASA wants to do a mission to Mars, he can provide the taxi service. He can provide the logistics to get to Mars. And he sees a lot of money here because it may cost $100 billion for NASA to build a spaceship and get the astronauts to Mars and perhaps leave them there or bring them back if they're feeling nice. Whereas Elon Musk is saying, well, hold on, we'll do the dirty work. We'll decide how we're going to get people to Mars, and we'll sell it as a service to you, and you pay us $2 billion for the service. Suddenly, not just saving money, Elon Musk is making a lot of money. His way of making rockets and his way of doing space is a lot cheaper than NASA can do. So basically, this is where he's trying to make a profit stream. Of course, we don't have business in space at the moment. We don't really, apart from communication satellites, we don't really have that motivation to make money in space. Elon Musk and SpaceX and other spaceflight companies are trying to find that need, and hopefully with a mission to Mars, they will fulfill a need for mankind to fund that kind of project. But I don't know. I mean, I'm still a little bit dubious about the whole Mars plan from SpaceX, but it's certainly exciting to consider.
I just want to interject here to say that it's not NASA's role to decide whether to spend $100 billion or $2 billion to send anything to Mars. It's the American people's role as represented by their elected officials. So if this is something that you want to have happen, it's your job to write to your congressman, your senator, and to the president to say, this is what I want. I want us to go to Mars. Please spend my tax dollars on it. Thank you very much.
I wanted to add a couple of things to what Ian was saying, that in terms of the money thing, I'm not sure, of course Elon wants to make money, but I'm not sure that's the prime motivation, because I've asked him about this and he said, well, if I just wanted to make money, I would just program a frickin' Facebook game and I could make more money that way. He's said many times that his aim is to make humanity a multi-planet species, and that sounds pretty woo-woo. But that's what motivated him to get into the rocket business, is to eventually get humanity settled on Mars. And so this whole idea of a Dragon mission, an unmanned mission to Mars called the Red Dragon mission that he's working on with NASA Ames, is kind of one of those first steps. He's also said that, he's also pointed out that the Dragon was designed to do a re-entry into the Martian atmosphere. They've built it with a protective system that is much stronger than really it needs to be, and that's why they've done it, so that they can port that into a Mars mission if they needed to. So he's really got his eye on Mars, and it's not just because that's where the money is, but that's where his heart is too.
But I think that's his genius as well. You know, he's taking his passion, but to actually make it a viable business model, he has to make money from it. Otherwise, SpaceX wouldn't exist. And that's what I find most exciting: the fact he's able to find a profit stream where the passion is. So we can learn a lot from him.
Yes.
All right. Well, I've got an interesting question, I guess, for the astrophysicists in this group. So Bill Giselle asks, when the sun becomes a planetary nebula, will Jupiter absorb enough of the stuff to reach ignition mass? Anyone want to crack that one?
No, its cross area is too small. So you have all of the mass from the sun expand, not all of the mass, you have the outer atmosphere of the sun expanding outwards, and some of that material is going to decimate what's left of the Earth. Some of it's going to decimate what's left of Mars. All the outer planets are going to get blasted with this material, but you can only get blasted with the cross-section of the material that hits your world. And Jupiter would have to get about 20 times bigger, and it's not going to get hit with enough material in its column of what it will gravitationally pull in and get whacked with dead on to hit that ignition mass.
So no.
Ian Dennison, you need monoliths for that.
so Ian Dennison wants to know, when do we get commercial spaceflight? Will we be able to settle on a single name? Will they be astronauts, cosmonauts, or taikonauts?
Somebody had a good suggestion. Ask Tychos.
Yeah. Anyone got a favorite?
You know, I kind of like the fact that there are all of these different words for it. We don't really need to be a mono-language planet yet.
Yeah.
I just go with space flyers, just because that takes in everybody. So you need a word like that for a headline.
Space flyers? Let's see if there's any more questions.
And you can tweet at us using the hashtags #CQX, #Hangout.
So Daniel Behringer asked a question earlier on. How long did the moon get locked into showing us only one face, and does this have anything to do with why the moon's hemispheres are so different? I guess that was based on your story, Pamela.
Right. So this is actually two completely different questions. Let me try and take them apart. So the first problem is, so currently we only ever see one side of the moon. So the moon is rotating as it goes around. It's just rotating at the same rate that as it's orbiting. So we're stuck always looking at the old man in the moon, which is fine. Now, eventually, as the moon moves out carrying angular momentum with it, I will not force you to understand the math. It's slowing the Earth's rotation as well. Eventually, in theory, if the Earth lasted long enough without getting blasted apart by the sun, we would lock so that we only ever faced one side towards the moon. That will happen if the sun doesn't blow it up, but the sun will blow it up, so we're not going to quite get to that stage without the experiment being interrupted by an angry star. Now, if you do go out and look at both sides of the moon, you'll find, as I talked about earlier, both sides are radically different. And we think that this may be part of the moon getting pounded on by a second object. So one of the new ideas, and we're still working out the details on this, is that the way the moon formed is you got a Mars-sized object that came in, crashed into the young, still kind of molten Earth. The lighter material splashed up, came together, not just into one object, but possibly into two objects, and later that second object pounded the backside, the side we don't see, of our moon, leading to a very different geological surface on the other side. This is a new theory, still working on it. Stay tuned for details. In March is the Lunar and Planetary Sciences Conference, and I expect to hear lots and lots of information about this there.
All right, so we're going to, I think we're going to wrap it up in just a couple of minutes, but I know there's sort of one public service announcement that I know both Emily and Alan are excited about, which is the Pluto stamps.
Yeah.
Who wants to take a crack at this? And Emily, you've got a possible guest for our podcast lined up, or our video cast, right?
Yeah, actually, Alan Stern, who is the principal investigator of the New Horizons mission, which is on its way to Pluto, is understandably very interested in getting New Horizons and Pluto onto a U.S. postage stamp. There's actually a change.org petition flying around right now. I'll probably be blogging about it soon, but it's not going to be hard to find the link, where you can write in to say, yes, please, U.S. Postal Service, we do want this New Horizons postage stamp. And Alan has agreed to be on the Weekly Space Hangout 2 weeks from now. So I'm sure he'll be talking about it then, too. But you don't have to wait until then to sign the petition.
That's
right.
awesome.
I wrote about this earlier in the week. I did write a little book about Pluto, and so I talked with Alan about this. And there's a process that folks have to go through if you want to have a commemorative stamp. And so it's very analogous to what happened with the Mercury Messenger mission, that you have to start 3 years in advance to get a commemorative stamp. And so Alan is doing this now so that by the time New Horizons actually does its flyby in 2015, there will be a stamp not only to commemorate little old Pluto, but also New Horizons and U.S. space exploration. So you can probably find links to the Pluto petition. I'm not signing it because I'm kind of one of those journalists stick in the muds, but I think it's a good thing to look over and support if you feel like it's worthy of support.
Yeah, you're very neutral on it, Alan. That's good.
Absolutely, yeah.
All right, great. Well, I think that wraps up everything. So again, I'd like to thank all of the participants for sharing an hour and not answering their phones.
Right on
we really
time.
appreciate that. So again, thanks to Alan Boyle, to Emily Lakdawala, Ian O'Neill, Nicole Gallucci, and Dr. Pamela Gay. Thank you very much for joining us. I'm Fraser Kane, and we'll see you guys next week.
Bye.